Hi, my name's Brian Oliver. Thank you for coming along to our future talk. So obligatory, what we are about to say may or may not happen, or has happened, or will happen. Who knows? As with all of these sorts of slides. As I said, my name's Brian Oliver. I work for Oracle. I predominantly work in the coherence team, or with the coherence group. So my colleague Mark.
Also on the coherence team. Coherence, if you don't know, is an in-memory data grid product, clustered. And so asynchronous programming is something that we focus on constantly.
We do a lot of this stuff. In fact, I think in order to like be in the coherence team, you basically have to think asynchronously all the time. And we're actually going to present this talk asynchronously. So this talk came about through just some experiences we had migrating some of the coherence internals. The coherence has been around like 10 years. I think I started using it as a customer about 8 years ago. Mark's been on it for 10.
Yeah.
So Mark has an internal knowledge of the coherence product, and I've sort of come in from the outside. And we basically built, well, Mark built, and the rest of the founders built, like all the concurrency stuff basically themselves. So things like Executor service and futures just weren't around. I think we were on
Java 1.2.
Java 1.2, yeah. So a lot of the stuff we had to build, and then eventually as Java 5 came around, we started refactoring and using some of the the stuff that built in the JDK. And obviously, if you build your own stuff, you get to make it the way you want it to be. But when you start to pick up someone else's API, even someone else's API in the JDK, then it's interesting because it's two completely independent designs. So, so this talk's we're going to talk a little bit about this. If you're sitting here and you're slightly confused, this talk is not about the future of Java, and it's not about future predictions about the future of Java. So we're going to talk about concurrent programming and our experiences with Java Future, and obviously the stuff that's related to that. So so you've got two options. You can go and have a free mark, or you can sit there and tweet or use internet and stuff. We thought it somewhat, I don't know, I think irony that we've got make Java the future on one side and why there's no future in Java. Java Future's on the other, but okay. Let's get started. So let's have a survey. Who does concurrent programming? Really, like creates threads? Wow, that's a lot of people. I thought it was only like Mark does it. Okay, it's quite a few people. So who uses the Executor service? Most people. Who's actually read the Java doc API about this stuff? Okay, less, which is scary, considering there's probably 20% of you doing stuff and never actually read the doc, which I would then assume you've not actually read the Java language spec on this either. Okay, so this is actually taken from the doc. Believe it or not, this is what the doc says. Future represents the result of some asynchronous computation. That sounds cool. And I'll quote Alex Sabich from last night. Alex, you wrote part of Spring.net and a lot of stuff with Spring and Java. Oh, there he is, behind you. There he is. And I think Alex said, it's all good when you look at the API, but the devil's in the details when you start using it. And that's exactly what we felt. So this looks good, right? Represents asynchronous computation. Methods provide, check if the computation is complete, wait for its completion, retrieve results. Well, this is all very good. And then we get to this one that says blocking if necessary. And we're going to talk a little bit about that.
I thought it was an asynchronous API.
Right. So it's an asynchronous API, but in the doc it says we're going to block. So let's have a look what we have. Get, because we use generics and get our value. Waits if necessary. So does it wait if necessary? Well, what does if necessary mean? Well, it means block unless you get an exception or you're interrupted. Or you can say wait for a certain period of time, unless some give up. Wait some time and then give up. So again, another sort of blocking call. You can cancel. You can say, "Is it cancelled?" or "If it is it done?" So again, this is taken. Okay, I added some comments, but this is exactly out of the Java doc. I just copied it in. So imagine we have this, archive searching thing we want to do. We want to be able to, search some archive for something, and it's going to return a result. And it could take a long period of time. And maybe there's, let's throw in some buzzword. There's big data behind it, or there's a database, But we're going to do something. We're going to take a string and say, find this and return a string. And that's good. But this is not an asynchronous API. This is just an interface to something that will search. Fair enough. But we'd like to do it asynchronously. Again, I just totally copied this out of the Java doc. And we sort of bolded bits to highlight it. So you can imagine, let's just say, no one probably does this here, but let's just see. Who does any sort of GUI programming? Yeah, there's a few. I know, put your hand up if you do. So if you imagine you've got a button, you press the button, and that button then just runs on a thread, and it calls show search, and you're passing the thing you want to look for, and you're passing an executor service that's going to use to provide some async workers, and you're going to pass in a searcher, and you'll do executor submit callable, do the search. So very good. This will kick off the search with our searcher, our archive searcher in the background, gives us a feature. And then what do we do? Well, do other things. Let's do other things. What would we typically... so do other things. Or maybe we won't do anything. But then what we do is this last bit. Future.get, which does what? Blocks. So if anyone who's doing like GUI development, is blocking the event thread a good thing to do? Hell no. Now let's imagine this method comes across a RESTful interface. Do we want to block the thread that's receiving that request? It's like a hell no, right? So sort of challenging here that the sort of infrastructure we have in the language says, yeah, you can do stuff async, but as soon as you want to try and get the results, one of the things that we typically do is just block.
And one of the things that gets me on this slide, so this is one of the ones that Brian put together, and I didn't realize initially that it came out of the Java doc, and I looked at it, and my primary problem is actually before the future.get. It's the display other things. So what's the point of that line? It's because it knows that you're about to block, right? So we've gone async, and we don't want to just turn around and waste this thread. So let's do something else. But for how long is the display other things? We're just trying to fill in the time, and so that when we get to future.get, hopefully the result's already there. So it's this filler. Like, it doesn't belong in this. It doesn't belong on the screen, right? That should be down on the floor, right? We care about doing that independently of this thing we forked into the background. So I was happy to find out that Brian didn't write this slide.
Yeah. Don't do reviews with Mark, code reviews with Mark. No, Mark knows he's asynchronous, and this is he's exactly right. Like, the whole point of what this is like, show the result of the search, and we go try to do the search and then do other things. Well, I'm trying to show the results of the search, so what's this do other things? And this sort of, as Mark said, like he thought I'd made this up. So no, I just copied this. I had to convince him to go into the Java doc. This is what the Java doc says. This is like an example. So it's sort of out of flow. It's out of whack a little bit here. So let's have a look at the executor service. If to use futures, and the talk is about this Java futures, we have to actually look at its sort of related class, which is executor service. And I mean, you can create your own futures and do a lot of other things, but predominantly we get them from the executor service or some subclass or some implementation of it. So we're going to talk a bit about the executor. So an executor provides methods to manage termination and produce features, tracking process of some async tasks. And by tracking process, we mean is done. Like that's basically it. Are we done? I'm not sure about you, but you know, if you've ever seen a GUI, everyone's seen a GUI. You know, you copy a file, you want to see progress. And it just sort of imagine it just sits there and goes, no, I'll tell you when I'm done. And then after a while it goes, done. Like this is not tracking progress. So that's my personal dislike of this. But okay, it has some methods to help us out. So we have, you know, we can submit a callable, and we know callables are things that will return values. You can submit a runnable, which returns a feature of, I don't know, which all we do is use it for saying, are we done yet? So you can monitor that. And then we can do invoke all with a whole bunch of tasks, returns a list of those features. How do we know that all of those things are done is an exercise for the reader. It's not, you know, you have to do that. The JDK doesn't provide any help. And invoke any is, I think, quite a strange thing. I've never used it, but I just want to know, does anyone actually use invoke any? No. Yeah. Like, here is some stuff I would like done asynchronously, and you just tell me when one of them's done, and I don't care about the rest. I mean, that, I don't know.
But I'm curious, how about invoke all? So, but we had everyone, or almost everyone, using the Executor service, so mostly submit? Yes? Okay.
Just submit. Wow. So we could carve that one out of JDK 8. We can just take out invoke any. It's a pretty good population, a sample. So, so styles of adoption. We see two styles. Mark, you want to?
Yeah, so this is the blocking, right? So, hey, Executor service submit, which is what everyone's doing. Eventually we do the future.get, and in the middle we try to, you know, make this thread useful. So,
and then let's block. Now, to be fair, we could also block with a timeout, but I see very little use cases for it. Very few people do that because it actually turns out to force this.
Yeah. So here, right? So now we'll poll rather than blocking, or at least we'll poll up front, so we can continue to try to do useful work until the result comes in. But again, back to my previous problem, like I'm intentionally like polluting my code, trying to do unrelated things, or I may be doing nothing at all, right? I may just be spinning on is done instead of blocking. And of course, there's potential value in that, right? The act of blocking itself has a cost, and if you're going for ultra low latency, spinning until the result's there could save you, you know, some time. But unfortunately, it also wastes the core. So yeah, I think I had missed on the previous one. We had the blocking wastes the thread, and the next one is polling wastes the core. Well, they're both bad, but I'd much rather waste a thread than a core. But unfortunately, we see a fair amount of this where people will just, you know, try to improve performance by spinning, and it works really well for them and sucks for everybody else in the VM.
And you know, we're talking about lots of like cloud stuff and like multi-tenancy. You want someone spinning a thread and wasting a core for you because you're a tenant inside that same JVM. Like, yeah, we should just stop this. So stop this. If you're doing it, don't do it anymore.
Yeah, you don't need the low latency.
You don't need low latency. So this actual example, this is a similar example out of Javadoc that we've seen. It just gets worse. So I say invoke all, I get all these tasks, and I got them in a list, and then what do? I want to iterate over them to see that they're all finished, and I'll just block. I'll just pick the first feature and I'll wait. The others may have finished. I may actually could be able to do something with the other results. Let's say MapReduce. Oh, cool, I needed to get MapReduce into the talk. So MapReduce, I want to be able to do stuff in parallel, but I'm just going to pick the first feature and just block on it and forget about the rest.
We could probably do a complicated algorithm like block and then, or spin once through, and then choose one to block, and then maybe for a timeout and then spin again.
Spin through the list.
We won't use all the CPU then.
No, that's safe, very safe. So again, not helpful, not very helpful. But you know, semantically correct code. But
yeah. And I have to say, again, this doesn't feel asynchronous to me. It's like something happened. We put something in the background, but our thread is completely synchronous here.
And that thread could be, as I said, like a thread from a UI, a thread from web service, thread from, you know,
Maybe it's in a thread pool, though. We can waste those.
Waste,
right?
because they're free.
Yeah.
So if you think about, like, if everyone loves MapReduce, if you think about MapReduce, this is not MapReduce friendly, right? Okay, so let's just step back and go, well, what are we really trying to do here? So when we get to the point where we have to do something in the background, what are the usual use cases? What are the things? Well, you either don't care if or when it completes, or you do care. I don't think there's any other options. You don't care if the task that you've said to do asynchronously completes, because it's going to carry on and do something else. You don't care about the exceptions. It's off on its own, and you've forked that thing off, and it's going to go away. Or you actually do care, in which case you want to do something else. If you do care when it completes, you actually want to do something with the result, or maybe the exception, or actually you don't care. Right? You care that it completes, but you're not going to use the result. And they're the sort of use cases that we see. So in summary, do you want to, in almost all these cases, you want to do something after something has completed. And that's what the previous examples have tried to show. It's like, do this, start doing the search, and when the search is done, display some results. But we try and inline that, and it forces you to block. And you've got no other way around that. So the API, unfortunately, forces that style of programming, even though what we need isn't that's not actually correct. So there's a bit of a mismatch there. So really, continuations are the key. So really, the idea of a continuation is to say, look, I'm going to do some stuff, and then later on, I want to continue on with same state plus some other state and continue working. So using continuations is very, very helpful. Java doesn't really have them yet, but we can get around this using abstract inner classes. So that's the way to represent like future work is to use continuation. Any thoughts?
I think moving forward will.
Okay. So.
Yeah, what's missing from the future, and what we need is a callback from the future, right? So far we looked at how do we know that the result is there? We have is done and we have get, but what we want is some way for the future to call us back and say your result is ready. If we have that, then what do we get? It allows us to know when it's complete and act upon it and act immediately. So when we talked about why would we want to spin, calling is done, it's to save on that latency. But if it calls us back, we get those same benefits by knowing immediately, being able to act immediately, but without wasting the CPU for the entire duration of the execution. So that removes the polling need, and it removes the blocking need as well. So now we're not wasting a thread either. And it allows for, as Brian was talking about, the continuation style. When we take action when the result comes in as part of that callback, it starts to very much resemble continuation style programming.
Which, has anyone started to look at Java 8 yet? Like, no. You should download it. There's some really cool stuff in it, particularly the Lambda stuff. You can get that build and drop it, and drop it on your machine. It's pretty cool. I actually ran the entire coherence test suite on it, and we're a little back from the future, but yeah, it was really cool. But when you start to look at lambdas and then you start to see this and continuations, you go, this stuff starts to fit together now. So
let's look at what it would take to fix the Executor service API and to fix Future to support callback style processing. The key thing is actually who's in control of the future. In the first line there, where we have Executor submit returning Future, is the current Executor service. But what we propose is instead you need to inject into the Executor service your own Future implementation, inject an observable Future rather than have one being returned to you. And kind of a fundamental tenet that we found is async methods should return void. If you're not returning void, you're returning something, which doesn't sound very asynchronous. And as it happened, it applies to the future results as well. So we end up switching to the pushing it in model.
And this whole concept of async methods must return void. Once you start doing that and apply that change to your code base, it's really interesting what happens. Like you naturally start using continuations, and you look forward. If you start to look at Java 8 and you start to look at Lambda and go, wow, this code is actually going to become a lot simpler. And you, as you said, like you're not blocking, you're not polling. So what would ObservableFuture look like? So we thought, well, ObservableFuture extends future because it's got to be future, and we'd have two methods on result of t. So the Executor service implementation would call us back and call our on result with the result, or if something happens, it would call failure with the exception that occurred.
Yeah, it's all fixed.
It's all fixed, right? Seems fairly reasonable. So let's rewrite the Java doc example. So a few things, like in the previous example we had throws interrupt exception. That goes away, right? We're doing this async. Handling the exception is just, part of a callback. So we have ObservableFuture. We create our ObservableFuture. It's going to return a string. When we do our result, then I think this laser pointer is not going to, it's not going to work. So when we do our result, we display the result. That's pretty cool. And on failure, we clean up. So nice and simple. Now we submit. That's pretty much from before.
And then we get to my favorite part of this slide is we get to remove this display other things mess from the earlier example. That's no longer the concern of the show search method, right? That's what happens after we return. That thread just continues on to do potentially unrelated work. We don't have to try to fill in a gap.
Right. We don't have to make ourselves feel useful between like submitting it and getting the result. And this is like GUI friendly, right? You're not blocking anymore. This is very friendly for user interface. It's very friendly for servers, right? And your talk you actually have a whole talk. It's not on this, but
yeah, I work on the Exalogic Exabus project, and it's about doing asynchronous networking and really applying patterns. A lot of this came out of that project, applying patterns like this to be able to push the network very hard in parallel without leaving a bunch of threads idling or spinning.
So you buy, say, an expensive Exalogic block, and it's got all this really cool InfiniBand stuff in it and all this awesome memory. What don't you want to be doing? Blocking and polling, right? Because often what happens is that expensive, cool infrastructure is just sitting there going, I'm just waiting because the CPU is doing some stuff. So this is, as Mark said, like came out of that work. Not this example, but
no, we don't have that in there.
So
yeah, the key here is a bit what we talked about on the previous slide. So one, we made the change from having the future given to us by the service, the Executor service, to injecting it. And then the other key change is, what do you do after you've submitted your work? Well, it's either future.get, wait, or you just return. So that's these keys: inject the future, return void, and then be able to just return immediately rather than turning around and waiting. So with the ObservableFuture, we actually are now both non-blocking and non-polling. Good stuff.
And Mark's comment before about returning the thread to the pool, right? You can just return the thread to the pool, right? It can now carry on and do some other work.
Yeah. Which, by the way, makes it much easier to size your thread pools when you're not wasting them blocked. So, for instance, we talked a little bit about Exabus, where we try to push to the limits of InfiniBand. And we want to use all the cores inside of Exalogic, so 24 cores. So how big should our thread pool be? Well, 24 ends up being a pretty good number because we don't waste those threads. They're either doing work or there's no work to be done. And so we don't need to, say, have 256 threads to try to do I/O processing. 24, one per core, is just about the right number.
Except if you're doing blocking and polling.
Which we explicitly disallow, it's the other thing that comes out of this, is you adopt this model and it becomes, I'm not going to do any blocking code, and I'm going to call your callback, but you're not allowed to do any blocking code either. And you can call other people's callbacks, but they can't do any blocking code. And if everyone embraces this, then all of a sudden your threads become really, really useful. They are just executing instructions. They're not sitting there waiting, and you can just push things through. And this, again, it gives you really big savings on latency because you don't turn around and have the thread go into a state where it's waiting for a notify, which, just to take this side tangent, we found that it's about 15 microseconds is the cost of trying to wake up an idle thread, at least on Linux x86, which, again, going back to InfiniBand, that becomes a significant portion of a network round-trip call. Is this 15 microseconds? It's just completely in process. And if we can shave that away by doing a callback and continuing the execution from there, it's a noticeable win.
So yeah, so the cost of going from one server to another server over InfiniBand, you can do that on a reasonable size object
in like 4 micros.
Yeah.
So you don't really want to add on 15. Maybe like 4 is like super low level, but even if we're talking about 100 where we've pushed very high up in the application stack, 15 is still, that's a sizable percentage.
Yeah. Well, I could do a lot more. Yeah. Notify Notify's wasting time as well. So. Okay, so again, we go back to continuations of the key. And if you look at it, there's the huge rage of being event-driven. It's basically like you're becoming an event-driven. It's becoming event-driven, sort of dealing with threads and asynchronously. So your future becomes a continuation. So, okay.
The aggregating future. So we started to look at, let's have some fun with our new toy. And so imagine you take this observable future and you create a collection of observable futures, and you hand those in as tasks, and each of their onResults method add to a shared results list that shared by all the observable futures. And then once all the results are in, you aggregate and proceed. It starts to look like MapReduce, and far more efficient than block, 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 block on the list. We're actually making forward progress as each result comes in, and the last guy in says, okay, I'll do the reduction stage. So it's like, oh, this is nice. We can actually get a little MapReduce style action with the pattern. But it's also kind of clunky.
It's a little clunky. We'll try and fix this. So who noticed that what we've just been rambling on about for the last 10 minutes doesn't actually work? Oh, one. I wish I had a gift, but you can get the gift of knowing that you're the first. Okay, so we didn't implement, like, ObservableFuture extends future, but there's a whole bunch of stuff that we just sort of waved our hands and just left out totally. So we forgot cancel, is cancelled, and is done. But do we actually need them?
I've been complaining about them. I don't want them.
Right. When you actually have to implement future yourself, having to implement those methods is really annoying, especially if you only need the first 2. So do we actually need them? Who votes yes? Ha! Actually, who's awake? There's a few awake. Okay, so we don't need these methods. So let's do something. And this is actually some of Mark's work.
Yeah. So this is what we use in Exabus rather than Future, and well, the interface certainly looks simple, and it's more generic than just trying to fill in the gap of what an asynchronous result looks like. It's simply tell me when something is available. So it's a fairly generic callback, but when we try to use it to replace Future, we can go to the next slide. We'll talk about what these methods are supposed to mean. So add is kind of synonymous to onResult. It's here you go. I have the result of your computation, and flush means I'm done giving you results, which goes back to add, which is apparently you can have add called more than once. In the Exabus case, we use this for streaming results in, but in other places where we're doing aggregation style, add could be used to give you partial results, and then flush is the indication that I'm not going to give you any more results. And you can see, or potentially see, how that can lead to a cleaner MapReduce style, right? Each add is giving you a part of the mapping, and finally the flush is the good indication that it's time to perform the reduction.
And if you're into MapReduce, that is. Like, everyone seems to be wanting to do MapReduce. Okay, so let's go back and refactor again. So now we use a collector, we create a collector, and we have add. This is where we had onResult. and now we have the callable, but now we also submit and we pass in the collector. And the executor service would call the callable, get the result, and then call add and put it into the collector for you. And then our collector would then do the work.
So all in all, very similar to the observable future style, but we left something out.
So yeah, we left something out again.
So exceptions, and this is one of the things that was interesting when we started using collector. It's how do you indicate failure? And it's somewhat of the problem is specific to how you're using collector, but in the case of futures, the first thing that came to mind is, well, normally we're collecting some object. Why don't we just collect an exception when there's a failure? Okay, so I can have a collector of question mark, and great, type safety, and I'll shove an exception in there when there's an error. So in add, I can always do instance of. And that was the first inclination, and pretty quickly seen as a very bad idea. Not only is it ugly, but sometimes you might actually want to use an exception object for something other than to indicate error, and to just say, oh, any exception, that means something bad happened.
And we've
really
totally lost type safety.
Yeah. Yeah.
Let's go back and make everything object.
Yeah.
So didn't want to do that.
So then the next thing, and I think this is...
So we argued at length, we really argued at length on this. And I was like, well, why don't we just have a on failure? Because what we did before in the ObservableFuture was the executor service or whatever's doing the executing of the task, if an exception occurs, it can just tell the collector, hey, I got, here was a failure. And it looked okay. I think I managed to convince Mark for a few seconds.
It uglied up the collector API.
Yeah.
Add and flush is just gorgeous.
Add and flush is gorgeous. And then I started thinking about what would happen in Java 8. If you notice the previous slides, we had flush declared as a default method. So it's stuff you can do in Java 8. If we had on failure, that would completely not work with Lambda. So I started losing the battle of this argument that we're having. So I went, well, I still don't like it. Come up with a solution. So
the kind of generic solution becomes you have to define a protocol between the service, which is performing the execution, and the user, which has requested it. But we also don't want to just say, it's up to you guys. So what we do is we say, well, you don't collect simply the answer. You collect the result of an execution, and the result can obviously be either the answer or it can be the failure. So we have collector of result of t rather than just collector of t. And from result, you can just call get and get your answer, or if it failed, calling get throws an exception. Unlike future, get is non-blocking. And by the way, you didn't get the result until it was there, right? You started with collector. Collector add was called giving you a result. You have it now. You just don't know whether it's an answer or an exception, and trying to obtain it gives you the exception, if there was one. And what's beautiful here versus using the on failure case is that your exception handling looks exactly like it would in kind of traditional Java, right? You get to use try catch versus on failure. What do? You instance of again?
Shut up. Which was my suggestion. That's the last thing you want to do. Oh, pass the exception. Let me do instance of. Hang on. Java has try catch blocks, and in 7 we have multi try catch blocks. So yeah. So I lost out totally in that argument. I think I still owe Mark a beer. But so now let's go back. Now look what it looks like. So okay, you have a result of string. Why didn't we just call it result collector? Well, actually, we do have an implementation which is just called result collector and it returns t. But we wanted to show the steps that we went through. So we have a collector of result of string, and now we add a string result, and we can say display get. So obviously, result.get's non-blocking. Feels like future, but it's not. And then if there was an exception, we then get the exception in the same way. And this is exactly the same semantics that future has when you call get. Right? So we borrowed a bit of the concept and use it here. And so starting to clean up. Like we now can handle exceptions. But we're still missing some concepts that future has. So cancellation, interruption, and we still don't yet agree on this, but we thought we'd argue it out, and we'll do a survey to see who wins. So what we do fundamentally agree on is that not everything is cancelable or interruptible. So future sort of gives you the chance of what's it called, cancel and may interrupt. You can pass in a parameter. And if you read the Java doc, it's sort of a bit loose. Like it may or may not cancel depending if it was started yet or not. And it's sort of up to the implementation what the behavior is. It's not completely clear.
But you can call it.
You can call it. You can call cancel and it may or may not do anything. But really we wanted to make it a bit more explicit. You know, that some things can be cancelled or interrupted and some things can't. But whose job is it? So this is where we started to like design the API again. It's like, whose job is it? Right? When you go to cancel something, should the request be on the task, or should it be on the result, or should it be on the executor?
And it's kind of funny, right? Looking at future, it's bizarre. You cancel the result. It really seems like you should be canceling the task. Although I think the continued point of debate is, do you cancel the task or do you ask the service to cancel the thing that it's running?
Right, and so we sort of went, if you ask the service, say executor service cancel this task, how do I know what task? And then to know what task, I'd probably need a ticket, which means my submit would have to return a ticket, but you know, async stuff has to be void, so I can't do that. So we basically think, well, you need a way of doing this. You have to be able to cancel. And we have actually two concepts. We have three concepts here, like the difference between cancelled and interrupted. So, you know, I think they should be separate. Like, you know, if I cancel something, it means make sure it's not done. Like, you can cancel something before it's started, whereas if something started, you interrupt it. And this is where we sort of disagree. So we introduced this notion of interruptible. You know, you can call interrupt and you can say, was it interrupted? And I wanted to add a bit more, and I'm slowly losing this battle as well. But essentially you have a wrapper that, you know, we can have an interruptible callable and an interruptible runnable.
Yeah. And what's probably important to see here, and may not be obvious, is that's our cancel method, right? We have one method. It's interrupt this task, and it's dependent on how far the task is made, whether it feels like a future cancellation or feels like a thread interrupt. But it's the I don't want it to happen anymore. Stop it wherever you can.
Okay, I agree with you. So now if we go back, well, we need to change result. Now before we had, you know, get throws execution exception. Now we can throw, and this is where I wanted to throw a cancelled exception or interrupted. I want to know if it hadn't started yet, in which case I get a cancelled exception, or if it had started, I get an interrupted exception.
And I want cancelled exception to extend interrupted exception, because that's too many throws.
So who agrees with Mark? Too many throws?
That's most of the audience.
Crap. I lose again. Okay. So how do we use this? Well, you have an interruptible task, and we just wrap it, and then I could submit it with the collector, and then, oops, so I can say task.interrupt. Okay, so now we can handle exceptions, we can handle cancelling and interruption, we can handle catching them, knowing how to deal with them. But there's a whole bunch of other things that I'd personally like to see when you start to deal with async. What about timeouts? So when you use future, the only real timeout you can say is you can time out on waiting for a result. You can't give a timeout for the task. So you imagine I have, you know, huge amounts of tasks to do, and I'm queuing them all up, say. Some of these tasks have a time to live. Now, we sort of could argue that the task time to live should be part of the task, and the task itself could abort. Or you could be able to say, look, I'm going to submit this, submit this callable, here's the collector, and here is the timeout. And then if the executor service gets to execute it, it can look at it and go, well, actually, no, this is timed out. And it can then basically create a result which, when you call get, will throw a timed out exception.
Which I think should also extend interrupted.
Which, because you notice I'm just adding more and more.
To me, it's interrupted means it didn't finish. You can catch timed out if you want, but I'm only going to throw.
You're only going to throw, right? We don't have to agree. This is how you improve. So this is another sort of one of my slight dreams that, you do something asynchronously. The first thing you want to know is, hey, how much has been done? Like, because with the future method, it's like, hey, go and do that, and then wait. So you can see in the log, right? Hey, submitted asynchronous job, ... waiting, and like job hasn't finished because I called future.get, and I'm just sitting there. I have no idea, like, where is that thing? How do I get feedback? So we sort of, we think there are two approaches, and we haven't sort of, to be honest, I don't think we've nailed the solution here. But when you have a set of serial tasks, task 1, task 2, task 3, task 4, you can, up to n, you can pretty much see some progress. Like, you can measure some progress through that. But that's extremely difficult if you have n processes and they're all done in parallel. How do you know how much is complete? So we haven't come up with a solution. One solution I think progress is a part of the result. It's part of the protocol. So I would say, look, progress extends a result, and I can, like in the case before, like I can add multiple results to the collector. I can add progress to the collector as well, and then I can, instance of, is it progress? How much have you done? Because really the task knows how much it's done. But that sort of falls down when you have lots of concurrent stuff.
Yes, I want to go parallel. So in my world, you know that you broke your task up or your job into 10 tasks, and once you've got 5 of those tasks back, you might claim 50% done. You might be not quite right, but the slider's going to be moving just the same.
Right.
But either way, it's the feedback the feedback via a callback that gives you some indication of how things are proceeding. That's important,
and the ability to actually be able to do that. I think that's one of the nice things about the result and collector, that you can actually put stuff into collector, and you can add semantics into collector around capturing these things. So we've been talking a bit about callables and runnables, but do we really need them? We've really been using the word task. So really, a task is provided with a collector, and the task can then add the results to the collector. Do we actually need callable and runnable?
I'm not there yet, but it looks like I could see going there. I still see the callable is a nice kind of atomic unit with its result value. What I do like with this, so pushing the collector in, is it lets the callable continue to push it along, which is nice.
Yeah, callable can only return one thing. Like call, return one thing. Task, because you're given a collector, the task could actually stream results back via the collector, because you can just say collector add. Task gets to the end, flush, done. So, and if you want to model runnable, because runnable doesn't return anything, it's like do stuff, collector, flush, finished.
Which, by the way, Executor service, right? That had a future of question mark, which when it was a void return, set a result to null, which is calling flush.
Which is the same as calling flush, the same semantics. But we don't have to return null.
Yeah.
So arguably cleaner.
Let's see, which one is this? The go parallel and continue. So when we look at our using a collector to do aggregation now, I think it looks quite a bit cleaner than in the earlier result early example when we tried to do it with observableFuture. Here we have two very distinct phases. We have when collector.add is called, and at that point we're just collecting our various partial results. And then finally, the framework is responsible for calling flush when it knows we have all the results. At that point, we can aggregate and then proceed, which is really the continuation part. So same abilities you had with our observableFuture result, but kind of it breaks it up in such a way that it kind of promotes the MapReduce style programming a bit more than with cobbling it together with a bunch of observableFutures sharing a single list result.
So remember back, we had the loop over a list of futures, and we just call get and grab one and wait and grab the next one. We had the version where we had add, but then we said, if this is the last one, then proceed. And then this is the clean version. So you don't need that if statement, have I got the last one, because we know flush is going to be called at that point. And we clearly break up the aggregation function of that list down to one value, and we split out the continuation. And in this case, like both of these two things are, those two methods are very Lambda friendly because they're stateless. And it's perfect for Java 8.
So I think this may be our last slide,
almost
or close to it. So here we kind of say you can have it both ways if you want. So if we didn't convince you that you should ditch future, we point out that if you have a collector-style API, nothing prevents you from writing something called a future collector, which implements future using the collector's callbacks, which is like, okay, big whoop. Well, what's nice about this is you implement this once. I guess we could do it for you.
Yeah.
And anything that takes the collector API, or really any callback-based API, you can just shove a future collector into, and you have your future-based API. You can't do it the other way. You can't build callbacks out of future. There's no hook point. So that was
if you do, it's very, very inefficient.
Well, you
have to
burn threads,
poll or block.
Yeah. So this is one of those, like, kind of winding all the way back when we first started looking at how we wanted to do async programming, and we looked at future or callback. We saw it's like, let's provide both. People like future and they're familiar with future, and then we said no. If we give them collector and we give them something like future collector, they can choose their style. But kind of as the provider, we only have to support one form of async processing and let you then choose your style. And obviously, as I said, if we chose the future route, you can't go this way. And it's one of a pet peeve of mine. You'll see in some async APIs, they can't make the decision between callbacks and future style, so they do both. So as you may have noticed from some of my gripes earlier about too many things in the throws clause or too many methods added to collector, I want the API to be crisp. So when there's two variants of every method in an interface, that is definitely not crisp.
Which is why you like my tasks.
Yeah.
Yes, I win.
So again, with this, it gives you that bridge in case you need to provide something more like a future API. It's there for your users, but
it's also there if something else takes a feature and you have to pass it in. Or if you've got some data structure with existing features and you need to keep that, you need to keep the same type safety, then this still gives you that. Gives you all of the same semantics. So we thought about, I'm uncomfortable with the word collector executor service, but I think you get the point, right? You want to be able to submit a task and you can pass in a result collector, submit a task, and maybe have some timeouts. But in terms of what Mark's saying being crisp, we'd probably take that method out as well, and then essentially invoke all. We'd get rid of invoke any. Okay. So that's all we have to say. And now we have questions. So. Yes, absolutely. So we could actually just make an extension to Executor service, keep the existing methods, and they just proxy them on and do the wrapping. Absolutely. We'd probably mix the two. We'd have callable Executor service as a separate interface, and then just mix the two into the implementation. Yeah.
That's key.
Yeah, it's excellent question.
Well, so technically it would be up to the implementation of the service, the Executor service. In our implementations, we call back from the same thread that just finished running your task, because as I mentioned, we don't want to have to wake up another thread to do the callback. We want to do it immediately, save those, in our case, 15 microseconds. And we've stipulated that your callback can't block, right? So go ahead, use CPU all you want, but don't block.
And one of the interesting things that we've done is on the Executor service, or sort of our implementation of this, is that that callback, like, let's say we know by some runtime instrumentation that we know that the task that you're submitting executes immediately. And there's no point, based on just runtime stats, there's no points in putting it on a queue, doing a thread context switch, giving it to another thread, executing it, then calling back on your callback. We could actually just use the calling thread. So the thread to use we can actually decide, right? We could use the calling thread. It's like, yeah, calling thread actually executes a task, then executes as well. Sure.
Are there any reference implementations of this?
I knew someone would ask.
Well, I think it would be fair to say no. It's if you looked in the jar file for coherence, you would find a lot of these classes, but it's at this point we're kind of using it internally, so subject to change, not reference implementation. But we've also kind of shown you. I mean, there's not really that much to it. It's more it's a pattern, but yeah, formalizing it for sharing would be nice too.
So there's two other projects that are going on. One is actually a spin out of the Coherence Incubator. It has pretty much exactly this. That hasn't been released open source yet, but it's coming out on java.net. It's called Oracle Tools. You can actually look it up, but the source we haven't had a chance to push it up yet, and it has parts of this. And there's another project inside of Glassfish, again, which hasn't been pushed out, which also uses this. It has exactly the same interfaces. So we're sort of like, okay, we have 3-4 different projects using identical interfaces. So we're now like, okay, how do we get this together? And like, you know, I personally like, it'd be cool just to put this in the JDK, right? Because then we don't have to write the interfaces in all these different projects. It's in the JDK. That's a different experience, just getting stuff put in the JDK. But that's obviously where I'd like it to go. But if you want to contribute or you know, move this into open source, that's very easy. We can work on that. Drop us an email. Happy to help.
Another question? It's basically the same style, right? It's really a presentation on callbacks, right? And what our team tends to do is invent it ourselves specifically for what we need, but then try to do it in a way that we aren't just doing it for that particular task at hand. We want it for the product as a whole. But basically, it's callback style. But yeah, it's completion handlers is very, you know, it's same concept. What bugged us is like Executor service and future is like that's the place you go to do async in Java, or the starting place. And didn't see it in there, but
yeah, I did. From what I said, it won't. Well, there's a couple. So, yeah, it's an interesting conversation which we probably could have off topic. The same with there's an observable task as well, but which is for use with the executor. But the whole point of that is to implement future. Even though the interface looks exactly the same and it has completion handles, the whole point of it is to implement future. Right. Cool.
Thank you.
Thanks.